Welcome to Level 5 Regents Study Guide. It's about to go down. We're going to be talking all about those properties of triangles that you learned. First thing we learned was the triangle inequality theorem. That is lesson 5.1. It's very simple. All it was this. The two smaller sides of a triangle have to be bigger than the third side. So a question might look like this. What set of numbers represent the side lengths of a triangle? Which of these could be possible? All right, we have three options here. The way you do it is you add the two smaller sides, in this case it'd be 2 and 7, and you check to see if it's bigger than the third side. 2 plus 7 is 9, that is greater than 10, nope, so this is not it. Second one, our two smaller sides, 5 and 8. 5 plus 8, is that greater than 13? Well, 5 plus 8 is 13. 13 is greater than 13? Nope, they're the same, so this is also out. Let's try our third one. 9 and 4, those are our small ones. 9 plus 4 is greater than 12. 13 is greater than 12. Since our two smaller sides are greater than our third side, that is our answer. Second thing, this is lesson 5.2, the side angle relationships. We want to list the sides from least to greatest, but the only thing given to us is the angle measures. To figure this out, what we need to do is draw these lines. All right, across from B is AC, across from C is AB, and across from A is BC. So we're going to do these least to greatest. So since the smallest angle is 40 degrees, the biggest side we follow this line across must be AB. Continuing, the second biggest side, since we're going up, would be 60, and across from 60 is BC. And finally, our greatest angle, which is 80, is across from AC. And we know that AC is bigger than BC, so we're going to put the greater than sign here. Remember, the alligator always is hungry, so he eats the bigger thing. And BC is greater than AB. The direction of these matters. When you're taking the Regents, don't get caught up. Sometimes you'll understand the whole answer, but you'll forget to use the greater than or less than sign properly. Make sure you're using this well. You have to know which way they're supposed to point. Lesson 5.3, the Midsegment Theorem. The line that connects two midpoints is the midsegment. All right? Don't confuse that with a median. A midsegment connects two midpoints. So that would be our midsegment. You might remember this, but a midsegment, if we double the midsegment, that is equal to the base. So 2 times the midsegment is always equal to the base of a triangle. So if I double this, I can get what my base is. 2 times the midsegment equals the base. Another example you might see is they give you the midsegment is, let's say, x plus 2. And they tell you that the base is x plus 3. To find out what x is, you would have to do 2 times the midsegment, which is x plus 2, equals the base. And you solve this question. So just double the midsegment, and that gives you your base. Boom! We be learning now, right, kids? Centroids. The centroid is the point where three medians of the triangle intersect. So where the three medians intersect is called the centroid. What is a median? This would be a median right here. All right, this is a picture of our median. The median connects the vertex to the midpoint. It's important to understand the difference between a median and a midsegment. The midsegment connects the two midpoints together. A median connects the vertex to the midpoint. See the difference? See that difference? To find the centroid, remember, you just find the three midpoints and you connect those together. And that gives you the centroid. So here's the midpoint, here's the midpoint. Draw those lines, and this would be the centroid, that point in the middle. Now, one thing that we know, remember the relationships here. Let me just get this out of the way for a second. All right, and let's make this nice. I'm going to draw some nice boom, and boom. All right. And I'm going to do some more labeling. Let's call this point E. Let's call this point G. And let's call this point F. Now there's relationships between the centroid and the parts of the medians. The first thing we know is that 1/3 of the whole thing, 1/3 of BD, 1/3 of the whole thing would equal FD, which is the smaller part, right? FD is the smaller part. So if I take 1/3 of the whole thing, that gives me the smaller part from the centroid to the base. 2/3 of the whole thing, BD, 2/3 of BD is equal to BF, all right? And that's the bigger part of the median. And since this is 1/3 and this is 2/3, FD is 1/3 and BF is 2/3, I know that 2 times FD, the smaller part, is equal to BF. So for example, if I know BD is equal to 9, 1/3 of that would be 3, 2/3 of that would be 6, and if you notice here, 2 times the smaller part equals the bigger part. 2 times 3 equals 6. Finally, 2 formulas you need to know, the Pythagorean theorem and the distance formula. The Pythagorean theorem, a squared plus b squared equals c squared. The distance formula, I'm not giving to you. Check your notes. You better know that. How do we use the Pythagorean theorem? Well, the only thing you have to know is that the hypotenuse is always c. That is the hypotenuse. How do you know which side is the hypotenuse? It is across from the 90-degree angle. So this is our 90-degree angle. So the hypotenuse is the longest side. Across the 90-degree, that would be 10. So in this case, if we were plugging in, it'd be 6 squared plus b squared equals 10 squared, because 10 is our c. Furthermore, this is a question that you might see on the Regents. Circle which of the following triangle side lengths could be a right triangle. How do we do that? All you have to do is plug these numbers into the Pythagorean theorem and see if it's true. So 3 squared plus 4 squared equals 5 squared. We're just plugging these into the Pythagorean theorem. All right, we're just plugging it into here. If the calculator says true, then it's possible. If it says false, then it's not possible. So if you put this in, you should get true. We'll check the next one. 2 squared plus 3 squared equals 4 squared. I put that in the calculator. It says false. And finally, 5 squared plus 12 squared equals 14 squared. Put that in the calculator and it says false. Now just to be clear about something, this question, circle which of the following could be a right triangle, is very different than this question, which set of numbers represents the sides of a triangle. Alright, these are two different methods. If it says right triangle, you plug into the Pythagorean theorem. If it does not say right triangle and still gives you 3 sides, then you use this method, where you just add the 2 smaller and see if it's greater than the bigger. Finally, if it says what's the length of a line, if it ever asks you the length, you use the distance formula. You just plug these points in. That is another typical question on the Regents. All you have to do is know the distance formula. When it asks for the length, use the distance formula. That's it for this lesson. Peace.